Hi, and welcome to week 3 of Maya Bifrost training. This week we're going to get started on our sort of feature film VFX shot. We're going to be making a section of this bridge shootout sequence using Maya Bifrost, which is its new procedural fluid simulation particle software. We're going to get started though by just going over how to create a basic Bifrost liquid from scratch in Maya, and once we get into that, you'll be able to create simple collision geometry like containers and colliding objects. And we're just going to talk a little bit about the importance of the scale of the scene with Maya Bifrost settings, because the scale really sets the accuracy of the solver. Next, we're going to have a look at our helicopter chase sequence. And I'll run you through all the different nodes and animation in that. And then finally, we're going to set up our bullets impacting in the water in a small section of the of the shot. And the reason we just simulate a section of the bridge is so that you can fine tune the settings of the scene without taking 20 hours to simulate. What we're going to do now is go into the visor and load up an example Bifrost simulation. And the reason why we're doing this to create a new Bifrost sim is because the scale is actually correct. So what I'm going to do now is just select this geometry and the Bifrost fluid, and then I'm going to delink all the collision objects and emitter objects, and then I'm going to delete this Bifrost liquid. So if I go and remove collider, and then I'm going to select the wave mesh that paddles the water. I'm going to go remove collider. Then we're going to select the wave emitter mesh and remove emitter. And then we're going to delete the Bifrost nodes that are in the scene. And we should pretty much have a sort of fresh scene then that's just geometry. There may be some node settings already on there, but basically what we're trying to do is just select the emitter and then create a new Bifrost simulation from this shot. So now we can select the Bifrost nodes and delete them. And this kill plane, we're not going to be using that for this tutorial, so we can move that out of the way or delete that as well. So the next thing we're going to do is just have a look. I'm just going to show you what's what in this scene. That's the collider object that we use to splash into the water. That's the beach collision shell object. That's the emitter geometry that fills at frame 1, and that's the wave paddle that pushes the water as we're going. So what we're going to do is we're going to create a new Bifrost water in this pond, but it's going to have all default settings, and we're also going to create a cube inside a cube beside it and fill that cube with Bifrost water, just so we can show you that it's definitely creating a new liquid. So the reason why we imported that wave paddle scene was this cube that's on the left is totally new Bifrost colliding objects, but if we'd had set the scale of this 1,000 times bigger, the simulation might actually not run correctly because the scale is too big in terms of size. Or if I'd set this box to be 100 times smaller, the scale of the water simulation would be too small. So you can always adjust this in the settings, but it's best to try and be careful with the scale with FX simulations. So if your geometry that you're using in your scene is too big or too small, the effects is designed to work at a certain size, whether it's Maya fluids, Maya particles, or Bifrost simulations. So one of the most crucial things is actually the scale of the scene as opposed to the animation or the accuracy of the collision geometry and things like that. So just be aware of that. So we're just going to emit particles now. So you go Bifrost, create liquid, And this actually is emitting the particles from the geometry that we've selected. So that's my two water simulations there. So the next thing we're going to do is set up the collider objects. So we've already removed this collider from the previous sim that we deleted. And all you need to do to add it is select the Bifrost liquid and press add collider once you have the geometry selected. And it'll say solid or shell, depending on how you want to fill that geometry. So this wave, we just go add collider, and that'll mean the water will be pressured by this wave. We're going to add this this ball collider back in again, and same thing on our new side. We're going to create a cube here that's going to splash into this fresh simulation, and we're just going to set a few keyframes on that and add it as a collider. And then we're going to add the container as a collider. So without the container being a collider, so we have to set that to shell so that it doesn't explode the water out of it. The container must be a collider so that it can hold the fluid. You can't just have a fluid emitter that has no container to hold the water inside it. So now that these are set up, these are really basic, but it's really important to see in a fast interactive scene how the settings affect the fluid simulation. And we have to set the frame rate correctly. So one of the first things is you need to set the start frame to 1 if the simulation starts at 1, and set the playback speed to play every frame. If you set it to real time, it's not going to be able to go through the simulation frame at a time, and it might skip over some frames. So it's very important that you set it to play every frame when you're doing particle simulations. Make sure it's set to viewport 2.0 and not high quality or another legacy viewport setting. That's really important because Bifrost only shows up in viewport 2.0 because of the huge particle counts, and they've specially written it so that it works with such billions of particles in this viewport 2.0. So now that we've got through that, we're now going to have a look at the simulating this with background processing, and then we're going to adjust the fluid settings. So one of the first things you need to do is get background processing enabled. So in order to do that, all you have to do is select the fluid, and we can see that background processing isn't running at the moment because there isn't the yellow frames on there. So if you go into Bifrost options, you can see that enable background processing is switched off. So if you press apply on that, what it'll do is it'll allow you to get that scratch cache working. And it's usually a good idea to delete and reset the scratch cache so that you can load it in correctly. And that's how you disable a fluid simulation if you want to not use it, so you can just work on one. So for the time being, we're just going to have a look at this fluid sim that's on the left hand side, that is the cube that we've created. So I'm going to set some keyframes now for this cube to fall into the water. So we've got 2 keyframes on there, and then I'm going to hide this. We see here it's got Bifrost continuous emission. We want to turn that off because that's like spraying a hose or a water fountain. This is just a fill object that just fills the whole thing with particles on frame 1 and then stops it. And you can see the beach has got continuous emission off on its settings. So that's why we've got these 2 scenes side by side, so you can check to make sure you have the right settings. So continuous emission off is an important setting for rivers and oceans and things like that, where you're not actually emitting fluids out of hose type geometry. You're actually just filling surfaces with it. So this is a very low res sim, and that's how many particles we can display. But I just want to show you, this is the default settings for creating it. So we can see that that cube falls into the water, and it doesn't actually splash. It kind of gloops through the particles, bloop, kind of like jelly. And what that means is that the voxel resolution is too low. So if we have a look at the particle setting on here, it's not just about having billions and billions of particles. It's also about having a proper voxel size. So the voxel size for the original beach simulation, it says in the little notes down the bottom, this voxel size of this sim is low for a best setting set to 0.08. So we can see our voxel size here is 0.5, which is 50 times larger than the recommended detail level for the water. But it's really fast to simulate, but you have to have a trade-off between being really fast and being really undetailed. So it's kind of like honey or glue. You really need to keep that fine, razor-sharp splashes of water detail for the particles. So the other thing you have to do is, this is the droplet threshold here. And what the droplet threshold does is it actually sets the ability for parts of the particle simulation to break off. So if there's a splash and particles separate from the main water, instead of just creating like a flat sheet of water that's all together, it'll create a spray so that you'll be able to break off some of the droplets, and then they compute not as water but as trigonometry, like velocity particles. So you can see here that even though we're adjusting the droplet threshold, because the voxel size is too small, it still hasn't helped us to create the splash. So if you're pulling your hair out wondering why your water looks like glue, it's because the voxel size is set incorrectly. So make sure to turn on voxels, and you can actually see in the scene the size of the detail of what you're working at. So at the moment we've got master voxel size 0.5. So if we change that from 0.5 to 0.1, when that updates, you see that you have a much finer, much more resolved water surface. So we can straight away see that that's gone from Play-Doh into a liquid, a very thin, detailed liquid shape. So it does take longer to simulate, but you have to set that correctly. Otherwise, you won't get the right behavior on your liquid. So if we turn it back to 0.5, it's just too blobby. So that doesn't necessarily affect the look of your particles. So just be careful that you set the master voxel size to either a sort of mid of the range number that gives you good detail and good speed to do your simulations, because it is actually designed to try and help you get a decent speed for your sim. So with our guy here, we can obviously see that we need to change the voxels. So master voxel size is 0.5 for this sim. So we're just going to flush the scratch cache, and we're going to go up to master voxel size and drop it right down. Once the master voxel size is set to 0.1, we'll have a much better simulation that will replicate the splashing, detailed water look that we're going for. So if you're having problems with the particle sim slowing down, you can change the max particle display count up or down depending on what kind of graphics card you've got. So what we're going to do is I'm going to simulate this and just pause the video, and then when it's fully simmed to RAM into the scratch cache, I'll give you a look at what it looks like. Now that we've simmed that to disk, to RAM, sorry, we can see that the little box that falls into this water, instead of just sort of glooping into it, it'll now splash correctly. So if you want to set the particle count up or down, that's where you can set it. I'm going to leave it at full particle display at the moment. And as we scrub through the timeline, we see the water hits into the fluid container, and the splash is much more detailed than the 0.5 setting that we had before for the voxel scale. So we can even set this smaller, but as you set it smaller, the simulation time will increase a great deal. So it's best to try and find a trade-off with the voxel size that isn't too slow, but it isn't too blobby as well, because you don't want to have your simulations take 60 hours a frame to run, but you also don't want to be showing gluey looking simulations to your client. So we've just deleted the other box sim so that we can clear up our scene. We're not being too precious about this setup, so we can really test it out and check the settings. So first thing we're gonna do is set the beach fluid to enabled in the liquid solver attributes. Then we're going to set the master voxel size. Now what you want to do is have a size that isn't too small or too big. So if you set it to 0.0001, you'll get a super nice fluid simulation, but it will take about 15 minutes a frame to simulate, which is just too long. So what we're going to do is set it to 0.015, and once I've run this simulation through, you'll be able to see that the water is much more realistic and detailed than setting the voxel size to 0.5. So I'm just going to pause the video and cache this through into the scratch cache, and then when it's finished, we'll play it back and check it out. So now we've cached this into the scratch cache, and I'm just going to hide the emitter geometry, and we can see that the way that this thin sheets of water has simulated is much more detailed and smooth than the original globby 0.5 voxel setting that we had. So you can see here, the second time it pulls over, it creates a little rippling wave that comes over the top, and when you mesh that, that'll create a really realistic flowing water simulation look to it. And that's the kind of detail level that's sufficient for TV commercials and TV series and things like that. Because you don't want to be having to re-simulate something that takes several days to put through the system. You want to be able to iteratively work with this water so that the client can have some kind of interactive feedback. So once it's meshed and we turn off the particles, you can see that this water's got some great definition into it. It's not too gloopy or blobby, and it's got like a good little wave happening there that looks a bit like the shoreline of a beach or a river. So that's the kind of look we're going for. So just be careful to set your scene scale correctly. And now we're going to have a look at the helicopter stunt sequence, and we're going to use this part of the wave section to put into the bullet hits so that we can fine tune the bullet impacts. So if you just open chase sequence without water version 01, that's going to be the right scene that we're going to use throughout this rest of the tutorial. So when that loads in, I'm just going to run you through the scene so that we can get a general overview of what's in here. So this is basically the scene from the start of this video tutorial, and all that I've left out is the Bifrost simulation. So if you first thing you want to do is, if you want to look at where the camera actually where the camera renders to, you can set the resolution gate on the camera, so that'll show you what the shot will render like. And you can see here there's no water in there yet, but I've got the animated helicopter, the bridge, the car driving along, and these kind of little sphere bullets that are smashing up. So I sort of threw this together pretty quickly. It's not really super finessed, especially the rigid simulation, because I'm just trying to create some messy kind of geometry that can splash into the water. And I've got some basic lighting in here as well, so that we can see how the scene is set up. So with Viewport 2.0, you can actually enable a lot of PlayStation 4 type graphics things like motion blur, and set the sample count. You can set screen space, ambient occlusion, and anti-aliasing. And once these are all enabled, as well as lighting and shadows, you actually get a really good sort of look in the screen that enables you to previs these shots really well. Especially the motion blur, it just seems to be super nice and accurate, and really fast considering how long it takes to render motion blur in Mental Ray and even the Scanline renderer. It's just a super good thing, the Viewport 2.0 settings. So this is the different cameras. There's camera 2, it's coming from one angle. Camera 3 is coming from the left-hand side. And you can see here there's a combination of debris that's set up as rigid bodies that have baked out, and particle simulations. The rigid bodies, because they're animated geometry, can collide with the water, but the particles won't be able to at this point because they're instanced debris. That's a helicopter there that's shooting out the bridge, and all you need to do is comp in some machine gun flashes on a card in front of that chopper in Nuke or in other comp software, or you could do it in Maya and render it out as a separate pass. But it's just a long bridge sequence, and enables you plenty of room to put in some cameras and make your own animation setup. So it's super fun to play around with, and because Bifrost is so fast, it's also fun to use Bifrost in this type of scene, because you're not constrained to like super tiny, small kind of water simulation sizes. You can actually make the Bifrost sim the total length of the whole bridge, and it won't bother the simulation too much. You can easily do this on a i5 computer with 8 gig of RAM and a $70 graphics card, because they've set up Bifrost to run on every man's kind of computer setup. It's not custom made for FXTDs using the high-end HP Linux computers. It's just designed for laptops and things like that. So you find you'll get awesome simulation capabilities on very humble software. So all that geometry there is the geometry that you can use to make your own fluid simulation of the whole length of the bridge. And those little green dots there, they're actually hand animated bullets that I've used to try and match up the bullet hits so that they made a nice random weaving shape. So it was quite a bit of work to get these bullets working, but the advantage is you can line up each one of the debris emitters, and each one of the water bullet impacts will be used as a collision object with those little spheres. And the good thing is, because they're spheres and they're just animated with keyframes, you can easily scale them up or down, or put different parameters onto the spheres so that you can you can make the water react differently. So if this is just like a little tiny machine gun, you can scale them right down small. And if it's like a 50 cal machine gun or missiles, you can have the spheres scaled right up with stronger values on them. So this is the debris emitters that are hidden, and you can see that they're lined up with some of the spheres that are coming through. So because my shot wasn't the whole length of the simulation we've got here, it goes from frame 1 to frame 190. So you should be able to easily get that a lot more sim time than I've actually got in my pre-baked out simulation that's been recorded. That's the fields that are affecting the particle simulations, and you can adjust the settings in those if you like. This is the scene lights that are casting the shadows. So you press 5 to go back to default lighting and 7 to turn on the scene lighting. And so that's default lighting and scene lighting. And this is great because it really adds so much more, so much more nicer look to your previous sort of renders that you can do for your supervisors to get that nice shadows and highlights and everything in there. So that's what it looks like with lights off. So I'm just going to turn polygons on so we can just see the stuff we want. And we also want to see plug-in shapes because that's Bifrost particles. So once that's turned on, we don't have all the sort of other stuff in the scene that we don't want to see. And what we're going to do is we're going to now set up our fluid simulation for these first couple of bullet hits. So how I did my scene that I tested out was after seeing the awesome beach sim that they set up in the Bifrost examples, I just basically brought in one of their examples scenes and then adjusted the properties on the water to get an explosive kind of splashes from the bullet impacts, because when they first were set up, it was too sticky, so the water wouldn't actually fly apart into spray. It would just kind of stay connected to itself. So all you have to do is go into Bifrost and go get Bifrost example and load in this wave paddle shoreline. Just be careful not to group the whole scene and rotate it around, because you're actually moving more than just geometry. You're moving nodes that are not meant to be rotated or scaled. So when you bring that scene in, just hide this reflection sphere. That's an environment for the scene. And we're just going to disable the Bifrost water. And once that's switched off, we're going to rotate and group this geometry that emits the water and is the wave geometry. So we can delete this little guy because we're not using him. So that's the Bifrost liquid. That's the water emitter mesh that's hidden. That's the collision container, and that's the wave generator. And that's the sine curve that's used for sort of twisting the wave emitter. So you need to select the sine wave handle as well, because that is what kind of swings the thing around. Now you need to group that, and then that way you'll be able to rotate it as a group without wrecking any of the position of the different parts of it. So the reason we did this in a smaller scene to start with is just for interactivity, because once you get into these big shots with all the assets and the collision geometry, you really can't muck around too much with the settings like you can in an empty scene, because what happens is sometimes it'll only play at like 1 frame per 30 seconds, and you won't have the luxury of tumbling the viewport and moving stuff around like I am now, because just the helicopter might have too much polygons because it's a film res asset. So I wouldn't expect your scene to be as interactive and quick as this if you're working on on film shots and putting in effects elements. So it's better to figure out your settings first and then just import it in and then make your changes. So we can see that the bullets are coming up through the water, and I'm trying to position this so that on frame 1, I'm not actually shooting bullets through where the sand is, because if the bullets miss the water and just go up into the air, it's not going to really have the look that we're after. So you've got to be careful to position it right so that you can get the water in the correct location. The other thing too is because you're only wanting to get the splash elements, the water doesn't actually need to be 500 meters wide. You can actually just comp in extra ocean on the edges of this water, or do another sim that overlaps this one that doesn't have as high resolution surface on it, because it's a bit of a noob kind of error to create literal fluid simulations that are like 90 meters wide and 500 meters long, instead of just focusing the detail on the area where the actual splash detail will be happening. Because out of the camera view, you can see a massive edge of water in both directions. So what we're going to do is add these parts of the bridge. They're going to fall in the water using shift and control. And we're also going to add the bullets, and then that stuff is going to fall into the water and collide with the water simulation. So these spheres are set quite small here because we just want to get a basic low caliber gun effect into the water. And if you want to make like a more powerful blast, you can turn on the radius of the spheres to be higher, and that way it'll affect the water more and it'll create more explosive blasts through the water. And all we have to do is select the spheres and turn the radius up in the attribute editor. So to make them collide, you go Bifrost Collide, which I've just done. And then now you'll see that any of these geometry that we've selected will have an extra Bifrost node on them that will say that they're a collision object. And all these collision objects should be solid, not shell. So now that we've set that up, we're going to get our Bifrost shape, make sure its setting is low enough so it's detailed. And then we're just going to do a simulation of this in the background and see how it looks. So you just enable background processing. And then in the Bifrost shape, you can turn on enable and enable scratch cache. So this voxel size is set to 0.1, which is quite detailed, and it'll be quite slow to simulate, but it'll give us really detailed results, which is what we're looking for. So once you've put your settings in for your voxels, you can set the particle display to off for a little bit faster response, and then all you have to do is press play and submit those frames to Bifrost for it to simulate them in its background process. So we're just going to pause that and reload it back in when it's finished. So I've done 95 frames of that Bifrost simulation, and when we look at it, it's done a really nice job of a really super detailed render of that simulation of that bullets flying out of the water. The other thing too is it's a good idea to do about 50 frames of pre-roll if you're doing these kind of wave, beachy, tide pool simulations, because it gives it a bit of extra time to shoot the first couple of waves through the sim to give it a bit more natural look. But we've just started from frame 1 just for time at the moment. So you can see here the spheres that come up through the water create these nice bullet impacts, and then the bridge wood that falls down creates a detailed foamy splash as it hits into the water. So you can see that there's these really nice tendrily looking explosive hits here. And this probably looks more like a an M16 kind of gun shooting at the car rather than a 50 cal. And this is what the final simulation looks like. So you can see our dodgy rigid sim moving around before it gets hit. But the main thing is the water. The water looks correct. So you've got these explosive little spheres coming up through there where it's the helicopter's shooting. And then the wood falls into the water. So that kind of really detailed look, if you're just working on a section of this, you can easily scale it up to be the full length of the road or wider, and it will give the same result except bigger. So that's why it's such a good idea to just work on a little section at a time and get the settings right. So in my final bullets, I found that this radius was a little bit too small for my my spheres that were colliding. So I increased their radius and also added some acceleration, and that also helps, which we're going to go into next week, which is influencing the liquid by the velocity of geometry passing through the liquid or velocity of geometry animated over the liquid. So we can see here that this is a really super nice, dangerous looking explosive water effect. Millions of particles. There's no way Maya would have been able to load that kind of particle count in previous versions that didn't have Viewpoint O. One thing you might notice is sometimes you get this kind of shearing effect of what looks like planes cutting off the particles. Don't worry too much about that because they're still ironing out all the different aspects of Bifrost's particle simulation, but it's one thing that I noticed when I was doing sims with it. And once this is set up to your liking, you can mesh this, and then you can render it in Mental Ray and check out how the geometry will look. So if we go down to meshing and we enable that, you'll be able to see that the meshing that turns onto it is super nice. So this hasn't got a very good shader on it in Viewpoint 2.0, but you can see that all the geometry detail of that giant foam explosion is right in there. And this isn't really needed for the spray. This is more for the main body of the water. And then you add the spray on top of this in comp. But you can see that there's just a huge amount of detailed geometry in there. And that just wouldn't be possible with noise or geometry with texture maps on it and even ZBrush to try and fake up water like this. It's really just a simulation thing that you can only really do with software like Bifrost. So it's just a really difficult thing to do on doing 3D modeling software to simulate water and generate meshes like this. So yeah, it's just a really good impressive result for this Bifrost. Super fast to generate the meshes and generate the particle simulations compared to other fluid simulation software, including their own Naiad, and the ability to visualize all this data in the viewport without any expressions or node graphs or things like that. It's just really awesome, and makes it a really powerful tool for generalist Maya artists. So you can see here from some of our different camera angles, if you imagine that going the whole way along the bridge, it just looks super cool. Next week, we're going to be having a look at how to set up more of this simulation, including setting up the Maya kill planes to stop any particles going off the scene, Maya Bifrost emitters, and we're also going to have a look at how to manage these larger Bifrost simulations. This one's 280 megabytes per frame once it's saved to disk. So you've just really got to sort of work a little bit differently once you're doing the full scale sim. But you can see here the detail is really awesome of this software, and it really just is so powerful to be able to create these animations and then just load water straight into the scene. So I hope you guys if you have any feedback or questions, please go onto the forums and post them and I'll answer. And also if you have any scenes that you'd like to see or sequences that you want to see done in Bifrost that you're really curious about, post some questions onto the forums and I'll see if I can get the scenes animated and set up for you guys, because it's so fun to set up. All right, all the best, and I'll see you guys next week.